applications. This should be also review because from previous classes, you guys had dealt with application problems that dealt with these different trig equations. And then, of course, solving equations. We're going to be looking at using your identities to solve a few more equations. We did some basic ones at the very beginning of this unit. Now we're just going to incorporate some identities to do some ones that involve a little bit more algebraic processes to them. And then that'll pretty much wrap up everything that's covering circular functions, realistically. Okay, so we've done the unit circle, we've done inverses, we've graphed them, we've solved them, we're looking at the applications, and we've simplified them. So that's pretty much the bulk of this this unit, especially with the reciprocal functions. All right, so let's go ahead and let's just take a look at an example. When you have something like this is cosine 3x equals negative square root of 3 over 2, and x is bounded in between 0 and 90. The thing is with this is that the domain is with respect to x, but we're looking at a 3x. So and we don't have an identity that has 3x in it, do we? No, we have one with 2x, which means we could probably rewrite it. If it was 2x, but with 3x, we're going to need to make sure that we adjust the domain so that way when we find our solutions, we'll be able to make sure we're including all of them. So anytime it's not with respect to x, you want to adjust your domain. So your domain needs to be with respect to 3x, which means you need to multiply both ends of your domain by 3. 0 times 3 is 0, and 90 times 3 is 270. So when you are finding the cosine of where cosine is negative root 3 over 2, you're going to be looking not between 0 and 90, but between 0 and 270. So between 0 and 270 on your unit circle, where's Yep, so that means you're looking at these three quadrants, but you're looking specifically where is cosine a negative square root of 3 over 2?
You're looking at
degrees, 90.
2 and 3.
150. And 210. Yes. Now, look at this question. Are we looking for degrees or radians? Look at that domain. Since it goes from 0 to 90, you know it can't be 90 pi. We're talking about 90 degrees. I know the symbol's not there, but we know all of our answers are going to be in degrees. Now, this is not what x equals. This is what 3x is equal to. So then when we actually solve for x is going to equal 50 degrees and 70 degrees. And if you notice, both 50 and 70 are actually in between 0 and 90, the original domain. Oh, you said what would you look at that? Okay, so if anything, this 3x is kind of like a parenthesis, which means that you basically got the x by itself by doing the inverse of cosine, and then I'm setting both equal to 3x. You can have something like this. Again, 0 is between, or x is in between 0 and 180 degrees, which means all your solutions should be in degrees, okay? A little bit of algebraic process to simplify this first before we actually solve. What should we do? And what's sine x squared plus cosine squared x? So this becomes 1 plus 2 sine x cosine x equals 0. What is sine x, 2 sine x cosine x? The double angle identity for sine 2x. So then we'll get this. And then if I continue to solve for x, because now I went from having 2 x's to just 1 x, I have sine 2x is equal to negative 1. Very similar in the situation that we had in the last problem. I need to adjust the domain because it's no longer with respect to x, it's with respect to 2x. And again, by changing the domain, you're making sure you're including all the solutions that would make the statement true. So anytime that's different, you want to make sure you make that adjustment. Okay, so now to find my solutions, I'm going to look between 0 and 360 instead of 0 and 180. And where is sine and negative 1? 270. If I only look between 0 and 180, I would have no solutions because there are no solutions where sine is a negative 1. So then that is 270. That's going to equal 2x, not x. So I got to divide by 2 to get, and then that is my solution, and it does fall within my original domain of 0 to 180.
Will it ever not fall in the original domain, or is that just a check?
It should. If it doesn't, that means you probably did something algebraically wrong somewhere.
So it's wrong if it doesn't fit.
Mm-hmm. Yeah, because you wouldn't be like, it would be like no solution if somewhere back up here, like in this step, like it wasn't possible to even get an angle.
So what you're actually finding is something that fits in the original domain, but what you're given isn't in the original.
Sometimes it will, depending on what the value is, but you want to make sure you include all of them. Let's look at this one. We have sine 2x equals sine x for x is in between 0 and 360. 0 and 360 are not included. So that means that all my answers should be, what mode? Degrees, 360 degrees. Now, one way that we can solve this, we don't want to adjust our domain because we have a whole nother sine x term in here. So that means we're probably going to have to use this identity for sine 2x. What's the identity for sine 2x? Now I'm trying to solve for x at this point, so what should I do? If I divide by sine x, I end up losing a set of solutions that are possible with sine x. Okay, if I divide by cosine x, I'm going to be creating a whole new trig function that I'm going to have to work with.
Okay, divide by no, divide by the other side. On the other side. No.
Why don't you move that sine x over? Because when you do, what do you see? You can factor out something that's in common. Okay? Getting rid of sine would, yes, it would create something that's a little bit easier, but the thing is you'll lose a set of solutions that you get from sine itself. Okay? Because once you factor out a sine x from both terms, you'll be able to set both terms equal to 0. And then you'll be able to find your solutions. So between 0 and 360 exclusively, where is sine 0? At what? Just 180. Because remember, sine is at your x coordinate or your y coordinate? It's your y coordinate. And that's at 180. Over here, I'm going to look where cosine x is equal to what value? 1/2. Where is cosine 1/2 from 0 to 360? 60 and 300 degrees. Please make sure that you know that unit circled because it's going to come into play when you are solving. So, okay, let's look at this one. You got cosine 2x equals sine x. I'm looking between negative 180 and positive 180. Now, one downside about cosine 2x, the double angle, is that you know there's 3 different identities for cosine 2x. So you want to make sure you choose the identity that will provide, or that will help you not do so much work. Which identity would that be? It would be the 1 minus 2 sine squared x. The reason being, you have a regular sine x on the other side of that equal sign. So if you get everything in terms of one trig function, you don't have to worry about 2 different trig functions in one problem. Okay? And this is nothing but a good old quadratic. If I subtract over the 2 sine squared x, or add over the 2 sine squared x, and bless you, subtract over the 1, I'll be able to factor this quadratic, set both of those factors equal to 0, and solve. This is how it should have factored, so you should have had sine x equal to 1/2 and sine x equal to negative 1. Okay? If you are struggling when it comes to factoring trig quadratics, then just replace it with a normal variable. Factor how you would normally factor this. Solve this how you would normally solve it. You would get x is equal to 1/2 and x is equal to -1. Just realize it's not respect to x, it's respect to sign, so then you just add on the sign at the end. Okay? It works the same way. Where is sine 1/2? Between -180 and +180.
Oh, no, wait, never mind.
It's 30.
30 degrees? No.
No, 30 and then
30 and 150. And then what about sine is -1? That was -90. That's how you use your different identities to solve equations. Questions?
Why would you have adjusted the
Because there was a whole nother trig variable that had just a regular x. Now if it was cosine 2x is equal to a number.
They were the same trig functions, but there was a double angle identity, then you can adjust it?
No. If there are two trig functions and one of them has x and the other one has 2x, then that probably means that you can use an identity to replace that double angle, so then it comes down to just a regular x instead of a 2x. The only time you adjust your domain is if you have a double angle or a 3x or a 4x and it's equal to a number. That's when you'll end up adjusting your domain. Okay? When it comes to your applications, get down what's important, okay? A lot of times if you ever have to create the equation yourself, you want to make sure that you create a cosine function. Cosine functions are always easiest. Do realize that sine and cosine functions, they have the same a, the same b, and the same d. The same vertical shift, the same horizontal shift, same vertical stretches and compressions, same horizontal stretches and compressions, and the same vertical shift. The only thing that changes is the horizontal shift, okay? And the thing is with cosine, it's a lot easier to find a maximum point, because you know cosine crosses the y-axis at a maximum, versus trying to find this middle point here after it's been stretched, shifted left, right, up, and down. Okay, it's a lot easier to find a max than it is to find this point on a sine function. Okay? A few things that you're going to need to know when it comes to a cosine function is the amplitude. Okay? Remember, we talked about this when we were talking about graphing. Amplitude is the distance between your midline and a max point or your midline and a midpoint. Okay? Algebraically, it is found by subtracting your max and min and then dividing by 2. Subtracting your max and min and dividing by 2. Your vertical translation is shifting the graph up or down. Okay? Algebraically define that. You take your max value, you add that to your minimum value and divide by 2. Very similar to your amplitude, but you don't want to mix up your pluses and your minuses. This is a review. It's all review.
Yeah, they remember. Well, bring back memories.
What's the formula to find your period? 2 pi over b. Okay, 2 pi over b. And then, of course, your horizontal translation. With your horizontal translation, it is the horizontal distance it takes for your graph to reach the maximum point from 0. So if you are given a function and your maximum point occurs somewhere over here, C is that distance it takes to reach that maximum point. This is what C is. So from 0, going to your right, however long it takes you to reach your maximum point, that is your value of C. That is your horizontal translation. Okay? Very rarely you'll be asked to write a sine function. I have yet to see any IB student write a sine function. A lot of times the functions are given to you. In general, this is the general form of a trig function. A sine bx minus c plus d. This is that amplitude I was referring to. This is the number that you use to find your period. That's the B. This is that vertical translation. The phase shift is the horizontal translation. That is the value, that is C. Okay, so again, how do you find C? It is however long it takes to reach the maximum from what number? From 0. So from 0 to get to that maximum point, that is the value of C. That is also known as your phase shift. Question?
If your max is like 3, 4, so it would be 3, your C would be 3, because
Yeah.
it would take 3 to get there.
Exactly. And the thing is, yes, there is a formula for phase shift, but the thing is that if your B is factored out of your inside, then you don't have to worry about a formula. The only time you have to worry about a formula for phase shift is if the B is written inside of the parenthesis, because then it will look like this. Okay? But IB puts the B on the outside. They don't put them on the inside. You won't have to worry about the formula for phase shift. You'll still be dealing with the horizontal translation, but you won't have to worry about the formula for phase shift. Okay? So, don't write this down. I am recording this so you guys can go back and get this example down if you would like. Okay, here's an example of an IB problem. It says the depth of water, h meters, measured at a C pier t hours after midnight is given by the function h equals a plus b sine 2 pi over k t, where a, b, and c or a, b, and k are constants. This is what I was talking about. A lot of times they'll give you the equation that you're working with. It's more so of a matter of can you find the a, can you find the b, can you find the c, can you find the d. Okay? It says water depth is at a maximum of 21 at midnight and noon, and the minimum depth of 13 at 6 and 1800. They always do time in military time. Graphically, what that would look like means is that the water is at its maximum height of 21 meters at midnight, which is 00 hours, okay? And then again at noon, it is at its maximum height. It's at its minimum height at 6, and then again at 18. And its minimum depth is what? 13. Okay? So roughly, this is what your graph looks like. Okay? This is what your graph looks like. Now from here, you're asked to write down the values of A, B, and K. Now if you look, A is the number that's being added to your trig function. What would that correspond to in the general form that I just showed you? Your vertical shift, your D. And the formula to find D is max plus min divided by 2. That is your maximum water depth, your minimum water depth. What's your max? 21. What's your min? 13. So you add them and divide it by 2. What's 34 divided by 2? 17. So that means this graph was shifted up 17. That means that halfway point on your graph is at 17. Okay? B, what does B relate to? It is your A, is your amplitude. That formula is max. So then that means I'm going to do 21 minus 13 divided by 2. What's 21 minus 13? Divided by 2? 4. So that means there's an amplitude of 4. And looking at this picture, you can see from 17 to 21, from that midline to a max, it is 4 units. From a midline to a min, that is 4 units. The last thing you have to do is find K. K is located underneath 2 pi inside with my variable. What number is there? Or what letter is there? I'm sorry. When it's being multiplied to my variable, that's technically your B. Okay? Because B would go with your variable if you were to distribute this over. Okay? So the formula to find B, or the formula that uses B is what? 2 pi over B, that equals my what? Your period. What is my period? 12 hours. Your period is the length of time it takes you to complete one cycle, or in other words, where the graph starts to repeat itself. Max to max, min to min. So from midnight to noon, that's 12 hours. Another way you could have done this, let's say they only gave you one maximum height and one minimum height. You take that distance and double it, you will get your full period. Okay? It's another way to do it. Now, when I solve this, well, actually, what is b? B in this problem is a whole fraction. So that's 2 pi all over 2 pi over k equals 12. If I keep, change, flip this, so k is equal to 12. Write down means little to no work. All of this is very little work. It's addition and division. Okay? Addition and division. This is nothing but keep, change, flip. And this is an example of an application problem that for IB. Okay? 4. It was worth 4. 1 mark here, 1 mark here, and 2 marks for K. So, on this example, since the following diagram shows a water wheel with a bucket, the wheel rotates at a constant rate in an anti-clockwise direction. The diameter of the wheel is 8. The center of the wheel is 2 meters above water level. And after 2 seconds, or after t seconds, the height of a bucket is given by the equation. Okay, so if the diameter is 8, that means your radius is 4. A is located 2 meters above the water level. So that means that the lowest point on this graph is at -2, and the highest point is at 6, because 2 plus 4 is given to you equals 6. It asks you to show that A is 4. A is related to the amplitude, which is the formula max minus min divided by 2. So then that becomes 6 minus the -2 over 2. 2 negatives make a positive, and that's exactly how you end up with 4. Now it says that the wheel turns at a rate of 1 revolution every 30 seconds. 1 rotation represents your period. So that means 30 is equal to 2 pi over b. To solve for b, you would multiply both sides. And as you can see, 2 pi over 30 reduces down to pi over 15, which is exactly what they wanted you to show b to be.
Wow.
And that's how you apply applications. The main thing is you got to know those basic formulas, okay? And then when it comes to solving, making sure if you need to adjust the domain and making sure you use the identity that will best help you solve the problem.